Let's study about some chemical properties of alcohols. Alcohols can react both as nucleophiles and electrophiles. The first one is alcohols as nucleophiles. Consider the reaction ROH plus CCS3 whole thrice plus gives RO CCS3 plus H plus. The bond between OH is broken when alcohols react as nucleophiles. The second one is protonated alcohols as electrophiles. Consider the reaction RCS2OH plus H plus gives RCS2OH2 plus, which is electrophile. On reaction with Br minus gives CS2RBr plus H2O. That is, bond between CO is broken when they react as electrophiles. Based on the cleavage of OH and CO bond, the reactions of alcohols and phenols may be divided into two groups. The first one is reactions involving cleavage of OH bond. The second one is reactions involving cleavage of CO bond. Click on the corresponding buttons to learn more. Let us understand reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. The first one is reaction with metals. Alcohols react with active metals such as sodium, potassium, and aluminium to yield corresponding alkoxides and hydrogen. Consider the reaction 2ROH plus 2Na gives 2RONA plus H2, and also the reaction 6 CCS3 whole thrice OH plus 2Al gives 2 CCS3 whole thrice O whole thrice Al plus 3H2. The reactions show that alcohols are Bronsted acids, that is, they can donate a proton to a stronger base, that is B minus. The reaction taking place is B minus plus HOR gives BH plus RO minus, where RO minus is conjugate base of ROH and BH is conjugate acid of B minus. The second one is acidity of alcohols. The acidic character of alcohols is due to the polar nature of OH bond. An electron releasing group, that is CS3, C2H5, increases electron density on oxygen, tending to decrease the polarity of OH bond. The acidic strength of RCS2OH is greater than CS2R2OH, which is very greater than CR3OH. That is, acidic strength of primary is greater than secondary, which is very greater than tertiary, where R is electron releasing group. Alcohols are weaker acid than water. Consider the reaction RO minus plus H2O gives ROH plus OH minus. This reaction shows that water is a better proton donor, that is, stronger acid, than alcohol. Alkoxide ion is a better proton acceptor than hydroxide, that is, OH minus ion. Hence, alkoxides are stronger bases than sodium hydroxide, that is NaOH. The third one is esterification reaction. Alcohols react with carboxylic acid, acid chlorides, and acid anhydrides to form ester. Consider the reaction ROH plus R-COOH in presence of H plus gives R-COOR plus H2O, and also the reaction ROH plus R-CO whole twice O in presence of H plus gives R-COOR plus R-COOH. Text. The reaction with carboxylic acid and acid anhydride is carried out in the presence of a small amount of concentrated sulfuric acid. The reaction is reversible, so water is removed as soon as it is formed. The reaction with acid chloride is carried out in presence of a base, that is pyridine, to neutralize HCl, which is formed during the reaction. This shifts the equilibrium in forward direction. Consider the reaction ROH plus R-COCl in presence of pyridine to give R-COOR plus HCl. Mechanism. You can here see the mechanism of the reaction of esterification reaction. The first one is reaction with hydrogen halides. Alcohol react with hydrogen halides to form alkyl halides. Consider the reaction ROH plus HX gives RX plus H2O. The difference in reactivity of three classes of alcohols with HCl distinguishes them from one another. That is Lucas test. Alcohols are soluble in Lucas reagent, that is concentrated HCl and ZnCl2, while their halides are immiscible and produce turbidity in solution. In case of tertiary alcohols, turbidity is produced immediately as they form the halides easily. Primary alcohols do not produce turbidity at room temperature. The second one is reaction with phosphorus trihalides. Alcohols are converted to alkyl bromides by reaction with phosphorus tribromide. Consider the reaction 3ROH plus PCl3 gives 3RCl plus H3PO3. The third one is dehydration. Alcohol undergo dehydration, that is removal of a molecule of water to form alkenes on treating with a protic acid, example concentrated H2SO4 or H3PO4, or catalyst such as anhydrous zinc chloride or alumina. Consider the reaction CHCS3 whole twice single bond CCS3 whole twice OH in presence of H plus and heat gives CCS3 whole twice double bond CCS3 whole twice plus H2O. The relative ease of dehydration of alcohols follows the following order: tertiary greater than secondary greater than primary. The mechanism of dehydration of ethanol involves the following steps. Step 1 involves formation of protonated alcohol. Consider the reaction CS3 single bond CS2 OH plus H plus reversible CS3 single bond CS2 H2O plus, which is a fast step. Step 2 involves formation of carbocation. It is the slowest step and hence the rate determining step of the reaction. Consider the reaction CS3 single bond CS2 H2O plus reversible CS3 single bond CS2 plus H2O, which is the slowest step of the reaction. Step 3 involves formation of ethene by elimination of a proton. The acid used in step 1 is released in step 3. Consider the reaction CS3 single bond CS2 plus reversible CS2 double bond CS2 plus H plus. To drive the equilibrium to the right, ethene is removed as it is formed. Fourth one is oxidation. Oxidation of alcohols involve the formation of a carbon-oxygen double bond with cleavage of an OH and CH bond. For example, CHCS3 whole twice OH gives CCS3 whole twice double bond O. Observe various types of oxidation reactions in aldehydes and ketones. The first one is RCS2OH in presence of CrO3 gives RCHO. The second one is CS3CH double bond CH single bond CS2OH in presence of PCC, that is pyridinium chlorochromate, gives CS3 single bond CH double bond CH single bond CHO. The third one is RCS2OH in presence of copper at 573 Kelvin gives RCHO. The fourth one is RCHOH single bond R dash in presence of copper at 573 Kelvin gives RC double bond O R dash. The fifth one is CCS3 whole thrice single bond OH in presence of copper at 573 Kelvin gives CCS3 whole twice double bond CS2.